Hey guys, my name is Brad Smerdell. I'm the electronics lead for Purdue Electric Racing, and I wanted to put a quick video together for you guys on a tutorial for Altium. Now, Altium's the printed circuit board software we use as a team to develop our boards and then eventually export it to a company called PCB GoGo that manufactures our boards, sends them back to us, and then we solder components onto them and implement them into our car. So to start things off, this is assuming that you guys have Altium installed on your computer. If you need help with that, you can contact me or the electronics chief, Josh Shao, or pretty much any existing electronics member, and they can lead you in the right direction. So assuming you have Altium installed, the first step after installing Altium is to go to the Google Drive. If you don't have access to that either, just let me know or Josh Shao, and we can figure it out from there. But anyway, you go to the Google Drive, you'll go to Per 2019, and you're going to go to the electronics subteam, and from there you'll go to resources, and you'll download this zip file of Altium libraries. Now once you do that, just put it somewhere convenient on your computer. It doesn't matter exactly where, but unzip it to a folder that's convenient for you, and leave it there so that Altium will point to it. Once you have Altium open, which we'll do right now, and again, if you don't have a login to Altium currently, um, let myself or Josh know. We can get you a license. But if that's too much of an inconvenience for the time being, any of us can log in for you temporarily into the Altium. In a few seconds, a dialog box will come up with a little login screen. There it is. Alright, and now that I'm logged in, you can confirm that you're logged in if you go to License Management right here. Just takes a second. There we go. And this little drop down, and it says right there that I'm logged in. Perfect. So now that we're in Altium, um, it's kind of broken up into two groups. There's a schematic development, and then there's the PCB development, printed circuit board development. First, you make your schematic, and then you import it into the PCB, and then you arrange it on the PCB board itself. And that's just kind of the general process of things. You don't immediately start putting things on the exact PCB. It's more of a paper start type of deal. You get your circuit board on the drawing sheet, and then you import it to the board afterwards. But first, before we do any of that, we have to install the libraries that we downloaded. So what you're going to do is go to the right hand side here where it says libraries. If you don't have that panel open, go to the bottom of the screen down here, bottom right where it says panels, and you should be able to find libraries right there if it's not already a tab on the side. See, then it comes up. So what you want to do here, these are libraries so that when I say you want a component to put in on the schematic, it actually finds the footprint, or in this case, the schematic symbol. So for this BJT right here, or some sort of transistor, it pulls this up. In other words, for like a resistor, it would show resistor symbol or that type of thing. So currently I have all of the libraries right here, but in order to get them to show up in this dropdown so you can place parts, you go to libraries. You're going to go to install, go to the dropdown, install from file. And if you go to install from file, you find wherever you downloaded and unzipped that zip folder from, and you're going to select all of these. The easiest way to do it, since it's in a nice file, is just Control A, and then you can hit open, and then you'll install them. And then once you install them, just make sure they're activated right here, and you should be good to go. Wait for Altium to load for a second. There we go. Alright, so yeah, I mean, like for example, the most common things are like resistors and capacitors. You'll find those right here under miscellaneous devices. Um, it has pretty much anything you can think of, little capacitors, diodes, you name it. Most of it's here. For resistors, we just go down here to resistor, and it shows you this up here is the electrical symbol, like the schematic symbol, and down below is the PCB footprint for the part itself. So to begin, on Purdue Electric Racing, the way we do this is as most members, you won't be making a new project, so to speak. You'll be editing an existing project that we have on our server. In order to connect to the server, go to the Welcome to Electronics page, and there should be a little like Altium installation document. And in that document, it shows you how to connect to the server we use for all of our projects, like where we host the projects, and that's called SVN. So once you have SVN configured, I'm not going to show you that in this video, but it's pretty straightforward. If you have questions, let me know. You're going to go over here to File, check out, and then right here it shows, the server you're connected to. And what we're going to do is go all the way to the bottom where it says tutorial. You're going to open tutorial. And what this does is it leaves the original file up on the server, so you're not actually changing what's up there for everyone to pull from. Um, it essentially copies it or downloads it to your local computer, wherever you have it set to. So for example, if I were to go here, go to documents, nope, yeah, excuse me, documents, go to my SVN folder here, tutorial, and it's right here. So these files that you see on the left here are essentially these files right here. So the general format is you have your project, and inside of the project there's a schematic file and a PCB file. Now you can have multiple schematic um, files in a project, and all that means is that um, it's more for like organization. You could put a bunch of different circuits on one page, or you could put all of the circuits on individual pages. So usually what we do is like we have all of the power distribution on one page, and then the next page would be like some sort of microcontroller signal, or some kind of I/O between different connectors, that type of thing. So this right here, as I said, is a schematic page where we have all of the symbols that you're probably familiar with seeing. There's a few concepts here, um, one of which is a net. So what that would mean is that like essentially this part right here doesn't necessarily have to be connected from here, say, to the resistor. What that means is, you can like the easiest way to do this is you do place wire, PW is the quickest way to do it, or you can go up here to place and place wire. So this would be the most intuitive way to connect two components. Would be simply just draw a wire from one to the other like that, and then you get out of it. Um, and then they're obviously connected, and you can actually click and drag something around, and the wire will follow along with it. But in some cases, we have components on multiple pages, and we use things called nets, or in our case, we're going to use ports. But you can use net. Net is another. It's the same thing, but the new standard this year for Purdue Electric Racing is a port. So you're going to go over here, say, you know, port like that, right? So you go in here, you double click it, and you can call it, I don't know, say it's power. Actually, to eliminate confusion, let's just call it signal 1. Alright, so I'm actually going to pull it off of this piece here, and what we're going to do is go here, place wire, PW is what I just did there on my keyboard, down and over. So let's say you want to connect just as we did before. We have this going to here, right? We can do signal 1 like that with that little tag, and we could place another tag right here. And what that does is the same thing as connecting the two wires. I'm going to go in here and go PW, place wire, place it there to there, right? So now these two parts are actually electrically connected. If you name this, um, not port, they have to be identical names in this little name property right there. So now they're connected electrically. So that's a simple concept in Altium that we use frequently. I just wanted to show you now before we get into the nitty-gritty of it, because after looking at a more complicated page, it is a little more involved. So I'm going to go ahead and delete this. This has the same deleting things. Obviously, you can Control Z, but like the selection lasso, as with most CAD packages, you can go to the left, selects anything it touches, whereas to the right only selects things that you completely cover. So, moving along, the schematic pages have the .sch is .sch doc is their file suffix, where the PCB is PCB doc. Just so you're aware ahead of time, I'm going to delete that. I'm actually going to I won't delete this stuff. I'm going to pull it off to the side because I'm going to show you how to actually get these components onto the schematic. Those are the components we will be using though. So before we actually show you how to actually no, we'll just show you how to bring a part in right now. So you go to libraries. Say we want to start with two connectors to bring in. We want a connector coming into this board. Say it's going to bring the power for the op amp. We're going to put together a little op amp circuit that's going to be a simple, like, amplifier, inverting amplifier of some sort. Just because that's a simple circuit that some of you may or may not have seen before. Um, if not, it'll make sense to you after like ECE 201 or ECE 207, which is the corresponding lab where you spend a lot of time with op amps. And you'll see them again in your future at Purdue if you haven't yet already. So you're going to go to bring in the initial connectors. What we use for the boards are called Harwin connectors. These are also connectors that are soldered to the board so that we can connect two mating connector pieces here and have signals leaving the board, say going out of an enclosure on the car to another enclosure on the car. What you do is you go here to the drop down. You're going to go to Harwin connectors. Whoops. And the part number is listed here, and it shows you the library it's in. The best way to do this is like if you know how many signals you have coming in or out, you can just look here, and the part number has like a 4, 04 is 4 pins, 06 is 6, so on and so forth. So let's go ahead and choose the 6 pin, and you just click on it, bring it over, you can place it wherever. Now in terms of placing these things, there's a few different gestures that you want to get familiar with. One of which is, well, before you place it, I haven't actually clicked to place it yet. I just clicked on the library tab on the right to bring the part in. You click place, or you click on it to begin placing it, and before you place it anywhere, you can hit spacebar, and it'll actually move it around. That will be convenient to you in the future. So then you place it, and it'll offer you to place another one. In this case, we're going to place another one just for the sake of so we have like an into and out of the board type of deal. So I'm going to delete these now that we have connectors on here. That's more of just a reminder to me of what parts we're going to be using. So a few things about Altium schematic parts. This little P question mark will come more into detail later once we have all of the electrical parts in here. But before we go any further, I want to explain a few things to you. So this little yellow box means nothing, but there's just a device on the sheet. This isn't necessarily, it's not like this is a little package of 6-pin like surface mount component, electrical component. It's not that. It's just like a generic box placeholder saying, hey, this is a part that will be on your PCB. And then below it right here is the part number of the actual part. So if I were to actually copy this, you can double click on anything to open up the properties. If I were to copy that part number and go to Google, and paste it, you'll see exactly the connector we're talking about. Um, Mauser. Oops. Let's go Harwin. Whoops. It's because I removed the last two numbers of the part number. So this isn't the exact part, but it shows you, um, you know, we do get a lot of parts from Mauser, so it's going to look something like that. Um, this is a 12 pinner guy, but it's the same general concept. We pull the part number, we get the data sheet from here, and Harwin's the manufacturer. But anyway, we have an XX here just as a placeholder for the last two numbers of the part number. We have a whole bunch of these parts already in stock in our shop at Purdue Electric Racing, so we don't need to order these every single time we want to solder a new board. But anyway, so we have this guy here, and we have this guy. We'll just put it off to the side over here. And what we want to do is we need to bring in a few things here. We need to bring in first the op amp, which I chose already. It's this LF356MX. That's just the like an LF356 op amp. If you go now, this is an important part. If you go, say like you're designing some circuit on a new board, the best way to find parts that will fit your board is to either go to Mauser, which is a very large electronics part distributor. We use them frequently, and it looks something like this. Or you can use DigiKey, which is another similar site. They're both just electronic part distributors. Um, if I were to put this part number LF356 into either of these websites, we'll find a part that works. So go LF356, throw it in. That's just the op amp that I had in one of my electronics kits already, so I decided that I wanted to use it. Sorry about that. My headset cut out. So to continue on, um, the next step was just to go. Whoops. So we found, what part was it? The LF356MX. Okay, so that was this guy here, I believe. We want to do surface mount. You can do through hole, but surface mount puts little pads on the board itself to use. So what I looked at here was, mounting style. Is this SMD SMT, which is surface mount, and the SOIC Narrow 8 is the package. So a bunch of chips come in the same package size, and that just makes it easier for manufacturers to put different circuits inside of the same thing. So the package is this right here. It's just 8 pins on each side, and then the circuit lives within this little black box. So we copy the part number once we decide that this is, the part that we want, and you can make a part in Altium for it if it's not in there already. This part I actually found already in Altium. The way I did that is we're going to go use this thing called the Altium Vault. Now this doesn't pull parts out of the libraries you have installed, but it pulls them out of the database of parts that Altium has provided to us. So you go here to you go down to the bottom right, you go to Panels, Explorer, and you're just going to go in here, go LF356MX, and hit Enter. And you're going to wait a second because it's searching through a lot of databases. So I chose the 1 in this case, and it shows you here the little 3D view of what the part looks like. So it shows you the black box. These little yellow things are the pads that you're going to solder to, and here on the right is the electrical schematic. Now we place it just by double clicking. Whoops, let's try that again. LF356. MX is what we wanted. I'm gonna hit right click and then place. There we go. And then you can place the part. And I'm gonna hit escape to get out of that and close it. There we go. Sorry about that. So I'm gonna delete this other one since that was just held there as a reminder. And we're gonna place the op amp right there. And it shows you the part number right there as well. Next is some smoothing capacitors. The best way to do this is to go up to libraries, go down to miscellaneous devices, excuse me, and you want to scroll down until you see cap semi. That's the one we use for this. If you're not sure what exact capacitor to use, you can ask myself or Josh, and we can help you out there. So we go down to cap semi, you just double click on it, bring it over, and we want a smoothing capacitor for both power rails, positive and negative. So I'm going to put that there and put that right there, and we're good to go. And that's good for now. So moving along, the next step would be to grab resistors for the gain of the, here I'm going to move this up a little bit, for the gain of the op amp. So we go again to the miscellaneous devices, and I'm going to go down to res 3 because that has the 0603 package, which is our standard package. We have a bunch of resistors and capacitors already in our shop, so we don't necessarily order these every time. The common footprint we use is this 0603. So make sure you have that selected when you go down here and you go resistor 3. We'll put one here and one there and hit escape to get rid of it. So now that we have the resistors and capacitors, I'm going to delete those, and we have essentially all of the parts we're going to use for this little project. So now the next step is to go and start putting in things like the power rail for the op amp. Let's start with that. So I'm going to go up here and make sure you save frequently. Whenever you hit Control S here, it saves it to your local drive. It does not save it to the server yet. We'll talk about that at the end once the project's done. So you go here to, in this case, we're just going to do another port right there on this side, and that'll be our positive 15 volts, and we'll go here, that's our negative 15 volts, and we'll go here for ground, and that'll be the ground for it. I'm going to flip this around by hitting spacebar. No, that doesn't work. We'll leave it like that. I'm going to go back up here, place one more port for the signal itself. We'll just go like this. How's that? Whoops. And place the port. Okay. So we know that these are connected because if I were to click and drag this away, you see how there's this blue line that comes up here? That's really important because we want to make sure that the parts are actually electrically connected. It's pretty easy to slack off and like put some parts down and realize that they're not actually connected. So we're going to go in here and call this 15 plus, since that's for the positive power rail. We're going to call this 15 minus, that's negative, and we're going to call this ground, GND. There we go. And then we're going to come over here, double click again, call this signal. And now we have to go PW, place wire, down. It doesn't matter what pin we use, but just for convenience, we'll go pin 4. There we go. So now we have a complete input connector here. These are all of the 4 signals that are coming into the board. Now, we can do the same for the output of the connector since we know it's going to be outputted. The only thing we're going to output, we're going to assume that the only thing going out is the signal that we're amplifying in the circuit. So I'm actually going to call this signal input and drag that out a little bit. And now you have to see, you have to make sure that this wire is actually connected. Pull it down, P, W, and up, and now it's connected. Okay, so next is to come over here, and we want to place another tag. We'll just place it right there. Whoops. And call it signal output. And click. And we'll drag this out so it looks a little better. There we go. Okay. Perfect. So now we have the complete I/O for the board completely done. We're going to have one connector for all the things coming in, one for all the things going out. We could have it on one connector since there's still pins over here, but depending on wiring and that type of thing and space restrictions, as well as if we were to like daisy chain the power rail of 15 volts to somewhere else, it might be more convenient to have another connector so you have the 15 plus minus going to another board, say that has another op amp on it or something like that. So next thing we want to do is hook up the power to the op amp, and the way we're going to do that is we're going to go here. Now theoretically we could go off of the connector and say, like I could just draw a wire from right here up to the positive 15 and call it a day. But we're going to actually do it with these tags since that's what we included already. And that brings up another point. There's the pin numbers here. You see that 1, 2, 3, 4, 5, 6, 7, 8, etc. What you need to do is go to the LF. This Mauser, you find your part on Mauser that you're implementing, and you go to the data sheet, and there will be a pin out on it, and that tells you what signal is on what pin of the chip. Alright, so it shows you a bunch of features for this particular op amp, the simplified schematic, that type of thing. We come down here and you can see the pin out right there. So 1 is balance, 5 is balance, 8 is not coupled or not connected. We're not going to use any of those. We're only going to use 2, 3, 4, 6, 7, and 7. So since we're going to do a non-inverting amplifier, or excuse me, an inverting amplifier, the easiest way to do this, just ground pin 3 and hook V plus up to 15, hook V minus up to negative 15, have our input signal on 2 and our output signal on 6. So to start things off, we're going to ground pin 3. So pin 3 is right here. I'm going to go place, and I'm going to do power port. Bring that down right here. Hit escape, P, W, place wire, and bring it up to 3. And now the non-inverting input is grounded. We're going to put this resistor on the inverting input, PW, and on this side we're going to do the tag, which would be signal input. Now as you can see here, we could just connect this signal input to directly right there, right? That's the same thing. So I'm actually going to do that in this case just for the cleanliness of the design. So I'm going to delete this port here, delete that little wire, and we'll do it again, PW. This isn't the cleanest schematic. Usually as I go I like to clean it up, but since this is just a tutorial video, you can do that as you like. This is just for the overall, learning how to go about doing this. So right here, this doesn't really matter right now. We're going to leave it at 1K. But you can set that to whatever, and there's a good chance that we have the standard resistor values in our electronics book. If it were a special resistor value or a special power rating that we needed for resistor, we could special order a part. And what we would do is we would come in here and we could just put the part number in the properties here. But we're not going to do that in this case. We'll just leave that at 1K. And if you've taken EC 201, 202, you know that it's just the negative of the feedback resistor value over the input, or the inverting resistor value. So we'll make it a negative 5 gain. So that would make this 5K. So if we have 1 volt coming in here, we have negative 5 on that side. Excuse me. Alright, so if we come back here, we're going to put that there, go PW, come down, go up and over, connect it, and bring it around to the feedback, just like that. Right? And now this right here is our signal output, actually, this node. So I'm going to go place, port. Actually, you know what we're going to do? Just for simplicity, we know that this is the signal output, so I'm going to delete that and go PW, bring it up over just to pin 1, and now we know that that's the output. Right? So now we want to hook up the power rails. So we come back over here. V minus is on pin 4. So we come back here to pin 4, that's right here. And we're going to put these little smoothing capacitors here. 100 pico is good in this case. This may not be a perfectly accurate circuit, but the whole idea is just that you get the idea of like how to put in components, that type of thing. So we're going to go PW, bring it in, connect to the capacitor, and bring it off to the side. And we usually do power going up as a wire. So there it is. Oops, PW. Boom. This little dot says that things are actually electrically connected. So I'm going to go place tag. I'm going to move that out. Whoops. See if I can't move that over. There we go, that's better. And that's even better. Okay. So here we want to change this name to 15 plus. And we want to go, so there's your, or sorry, not 15 plus, 15 minus. And we have our smoothing capacitor here going to ground, so we're going to go place the power port, which in this case is ground again. Now we could just connect it up to this ground right up here. But again, make sure it is actually connected. I'm going to zoom in here. Control plus the scroll wheel is zoom. And now we have that connected. Another thing, if you hold down right click and move around, that's panning. Control and scroll is zoom, as I said. If you want to scroll up and down, it's just a scroll wheel. If you want to scroll left and right, it's hold shift and scroll. All of that's convenient. So now we have that capacitor up there. We want to hook up this smoothing capacitor to the positive 15. So I'm going to come up here and go place, not part, place port, not part, port. Call this 15 plus, PW, place wire, bring it down to there, bring it down to here. Now you see there's no dot right there, so that means those are not connected. I'm going to pull this out to make it look a little cleaner. And then the other thing to do is just put this to ground. Place power port right there to ground. PW, and we're done there. So that's 100 pico, that's 100 pico, we'll just leave it as that. And I think that's it. Yep. Alright, so we have all of our component values in here. The next thing to talk about is the designator. Now this tells you which part is going to be connected to what on the PCB, as well as it puts a little text on the PCB so you know what part you're referring to when you're looking at the PCB and you're looking at the schematics. So what we do is we go up here to where is it? Okay, Tools, Annotation, and you go to Annotate Schematics. Alright, so what we're going to do is go Update Changes List, and we're going to go Accept Changes. We're going to go Validate Changes, and make sure these are all green, and then Execute. And what that does, it's all a little methodical to Altium, but you see now instead of P question mark, it's P1. So that refers to connector P1. That's our input connector. Over here, you'll see a P2, that type of thing. We have C1, C2, R1, R2, and then U1 here. So there's our finished circuit. Not too complicated. We make use of the nets here so that even though it doesn't look like anything's connected to the 15 plus here, 15 plus here is actually electrically connected to this 15 plus. We could place a wire from here down to there and it would be the same thing. And that's it. So the next step, again, make sure you save. We're going to go over to the PCB dock, which I have included here, and you open it up. And you're going to see that it's empty because we haven't actually put anything into the PCB yet. And here we are. This right here is the PCB. If you hit, there's a bunch of different views. If you go 1, it gives you the PCB editing view if you want to change the size of the board. 2 is the one for routing the different things. And 3 is a 3D view. If you hold shift and right click and drag around, you'll see a 3D view of the board. So the first thing to do is to import, give me 1 second here, make sure we're still recording. The first thing to do is to import the design or the schematic changes we have there. So all the stuff on this page has to be put on the board on this page. So the first step is to go to design and don't do import or update schematics. Sorry, let me make this very clear. Do not do update schematics in tutorial project PCB. What that does is it's going to take all the stuff we have on this document right here and make the corresponding changes back on the schematic page. So in this case, what that would do is completely wipe out this, or it would leave this page as it is, but it would delete everything on this page because there's nothing shown on the PCB right now. If that doesn't make sense, this next thing I say will. So what we do to get all of the schematic stuff in is to go to design, go to import changes from the PCB, or from the schematic, and we're going to validate the changes. Don't worry about the class member. What we're going to do, I like to unselect this room. What that does is it just puts everything in a little group. Some people like them, others don't. That's up to you. Um, you can look it up online exactly what a room is, but essentially all of the parts should stay within that box so that you can move things around easily and organize it. So then validate and then execute. See, everything's imported in now. And if we scroll over here to the right, you can see all of the components on this board. So obviously this PCB board we have here is much bigger than the components we're going to be putting onto it. This black box is the board itself. If I go into 3D view, you can see the parts here. So we have, if I zoom in, you have the 2 connectors. Here's your op amp. Here's your resistor, your capacitors, that type of thing. And it's actually a really cool little 3D model of exactly what the parts look like. So I'm going to go back to the PCB editing view. I'm going to just drag things over. The general way to do this is that, there's things that need to be close to each other, like smoothing capacitors are close to the op amp. Connectors can be as far as you want away from each other. So if you zoom in here, this is what the actual board is going to look like. It's going to print this P1 here for this connector is tied directly to this P1 right here, which is this connector, which is the whole purpose of this designator that we put in through the annotation tool. And then what it does is it gives you a little 1 and a 6 here in the dot, so that tells you that this right here is pin 1, 2, 3, 4, 5, and 6 when you come to soldering and that type of thing. So we're going to put the other connector, we'll put it next to it. And there's different features, like you see that little vertical line that comes up that tells you that they're vertically aligned, and that type of thing. You can do things like, if I were to right click on this and go to align here, you can do a bunch of different things so that it's very organized. We'll bring in the op amp itself. We're going to bring in the capacitors. down below, bring it all over. Alright, so as we said before, the general way this goes is, we have the power coming in to the op amp, and the only thing leaving is the signal. So there's only one pin on this connector being used. All of these little faded lines you see are connections that need to be made but have not been made yet. Now the way you make electrical connections on a PCB is through traces. Traces can be on either the top or bottom side of the board. The way you flip which layer you're on is down here at the bottom. That'll make more sense here in a second. So we put this up here, and I'm going to actually keep hitting spacebar until everything is fairly well clear as to what's going where. So that looks like it makes the most sense. I'm going to put the capacitors near where they need to be. And as you drag it around, you can see that there's a ground on the connector there, and there's also a ground on the little chip. So I'm going to put C2 right here. I'm going to put C1 near this side, just like that. And then the next thing to do is come over here. R2 is our feedback resistor. Resistors don't need to be as close to the board, but in this case we'll just leave it where it is for simplicity, and say we'll put that right there. And the next thing to do, we haven't actually made any electrical connections yet. We just put the parts on the board. If I go again to the 3D view and scroll over, you can see it's going to look something like that. Alright, so the next thing to do is to add the traces. You go place, you go to route here. And what I could do is go active route, and what that does is it'll route the whole thing for us. We don't always use that, just for the fact of, like, say there's power connections that need to be like larger trace widths, that type of thing. It's better to do it manually so that you make sure everything's connected as you would like it to be connected. So what we're going to do is go to interactive routing. Or is it active routing? No, it's definitely interactive routing. Go to interactive routing, and now what you do is we come down here. We'll start with where we started before. So we go zoom in here, and you want to make sure the little green circle comes up. You go to pin 1, and that's obviously your power. So we want to stick to as many 45-degree angles as possible here, just for the fact that that's the standard of PCBs. It's not 100% proven that 45-degree angles reduces the overheating of boards, because if you do 90-degree angles, it's said that the current flows into the edge, or the far side of the trace, and that leads to overheating of the boards. That's up for discussion. There's no real answer for that yet, but we're going to follow the standard of 45-degree angles. And another good thing to do here is to put red means the top layer of the board, blue is the bottom. So it's usually beneficial to go so that you don't have two traces running into each other. It's better to go red as a cross, I'd say. So that can be anywhere around here, even if you go over this writing right here. So you're going to go up and down into it, not with a 45-degree angle. We'll fix that in a second. You get the green circle and you place. So you come up here, actually I'm going to hit escape, zoom in on it, and we can get rid of the 45-degree angle just like that. So something like that is acceptable. I'm going to go in here and go PT again, place trace is the quick way of doing it, over and up. It's as simple as that. I'm going to do it again here, but what I'm going to do, actually no, since there's no connection there, we'll just do it like that. And we go in like that. And you can always zoom in on things like this here, and you can see the different parts. You can just get it. It just needs to be on the pad like that. So that little tiny thing going on right there didn't need to be there. We zoom out and we can do it again. What I want to show you though is how this can be done on the blue layer. The blue layer is the bottom layer, and the way you switch from one layer to another, say like this C1 here, we have to get it down here, but there's stuff in the way, obviously. Actually, in this case, there's not, because you can take a red trace down here just directly to there. But what you do is you do something like this. You go place trace on the red layer. You would go over. You would place, and you hit escape and go up here to place via. Whoops, sorry. Go place via. And what a via is, it's a hole in the board that takes a trace from one side of the board to the other. And the reason you would do this is like, say you needed to connect across, you need to go across this here to get down to there, to get down to this pad where we're trying to get to. You'd place this via, and then you'd click down here on the bottom layer. So we're placing on the bottom layer. You'd go P, T, and you'll see that this trace is going to be blue, just like that. So you bring it over, you can place blue, and then do PV, hit escape, do PV again, place it on there, go back to the red layer, PT again, and this will be red, and you can bring it in just like that. Fix the 90-degree angle. That was pretty bad. There we go, perfect. Now, again, this isn't the cleanest PCB design, but I just want to do this so that I can show you how to go about vias. So the typical standard we follow on things is like red is one way, like on the top, going left to right would be red, and going up and down is blue. And that's just so that you don't run into problems where you're stuck and you're placing vias everywhere, all over the board. So we're going to finish this now. If you come in here, go red to there, down to here, just like like that. You want to get rid of as many of these little things as you can. In this case, it doesn't look like we can do much except that. Alright, so now that comes down to here, and we see that there's a trait. This is the output here. It's coming down and over. And after you place a trace like that, you can always come up here and edit it so it's cleaner. PT, up and inside, clean it up a little bit. Just like that. PT again. Place that to there. This around to there. This is really bad. Let's clean that up. Something like that. And this guy right here to the smoothing capacitor. Like that. And we go here down to there for something like that. Alright, now everything's connected. And what we're going to do is come up here, and you can go now to here and you can see the traces. This is on the top side of the board. You can see that it's very faint here, but there's your via to get that trace over to here and around. If we flip the board around, you can actually see the trace on the bottom side. See it right there. So that just makes it easier to route signals across boards, that sort of thing. So it's all done. And that's pretty much it. I mean, you can add things like documentation onto it. So if, say we want to add what is it? Component 3 valid eval. I don't remember. String, here it is. So like say we wanted to say we place that string and call this like tutorial board, and we don't want it on the top layer, we want it on the top overlay. So we scroll down to top overlay, and now it shows up there. So if you go to the 3D view, see it shows it as right there, just like it does the designators, that type of thing. Control S, save it again, and that's about it. There's a few other things you can do. You can do things like, there's more complicated, complex types of strategies, like pouring polygons onto the board for ground ground planes, so they don't have grounding going everywhere, like ground traces going everywhere. Excuse me. As well as things like You can cut a hole in the middle of the board or that type of thing as well for things like, I can show you an example of a board that I designed. If you go to checkout, DC, download it, go to the PCB, it's loading. There we go. Now this is much more difficult to look at initially. This whole red thing here is the ground plane for the board. This board essentially just converts 300 volts from the battery into our 24 and 48 volts on this side. So, you have your connectors here. These little Harwins up here are the ones we used on the tutorial. There's the resistors there. There's a couple MOSFETs. And then we actually cut holes in the middle of the board here for these two bigger components called Vicors. As you can see, they are mounted on the motor controller itself. Whoa. So there's actually holes in the board. I just wanted to show you an example of another board that, a complete board after it's gone through manufacture or a few like design phases, that type of thing. And that's about it. So we'll close that. We're actually going to close the DC-DC project too, since we're not making any changes to it. There's a few other steps after this that I will do as the lead, or Josh will do as the chief for electronics. Things like adding a keep out layer on the entire board for manufacturing of the boards and that type of thing. But there's really not much else. If you have any other questions, let me know. But as you can see here, there's one last thing I want to show you. It's the tool called Design Rule Check. And what this does is, you can configure like all of Altium to a bunch of different rules, things like routing of parts or routing of traces and how close they can be, the width of the route and that type of thing, where you're allowed to enter surface mount parts, placement of parts, it's like how close to the edge of the board, how close to other components it's allowed to be, whether it's in a room or not, that type of thing. If I run just the default rule check, we shouldn't see any errors come up. Where is it? It's still running right here. If you look up online, you can find a bunch of other Altium tutorials if you're more interested. There's a ton of like different ways to do the same thing. Like placing vias, I think it's either tab or the tilde button. If you're on one layer, you can hit that and it flips you to the other layer automatically and places a via wherever your cursor is. There's things like, there's tons of things. Like the auto routing is pretty cool. In this case, we could have used auto routing after we placed the components on the board. There's the rooms, as I talked about, to group all of the parts together. You can place 3D bodies inside of here so that you can use those as like placeholders to see how well your board fits into something. I could take this PCB 3D view and export it as a step file so that you could import it into something like SolidWorks to see how well it's packaged into the car, and things like that. The DRC design rule check is still running, so we're just going to sit tight for a second. And feel free to look around and check out different projects that we have done already on Purdue Electric Racing. Some of the bigger ones is like PDU, which was our main board last year. Something like the wheel module is a smaller board that we'll be working on again this year. And like pre-charge, discharge, those are all boards that are currently on the car, as well as the pedal box too. It's another big one. So in a second here, it's going to export the design rule check. Almost done. Any day now. I think it's taking a while because I have my computer on balanced energy mode and not high performance. See if I can change that right now. Oh no, it's on best performance. Come on. Shouldn't have ran this. I should have just told you to look it up and do it on your own time. It's pretty quick and easy um, to figure out. That is not, as you can see, not to actually run it in this case. Save the project. Alright, so let's move on as the DRC is finishing up its thing. So the last step to do here, um, if you wanted to commit, like say you were done working on your project and you wanted to um, add it to the server where we keep all of our boards. Now this means, like as of right now, the changes I've made from what I pulled from the server. Remember when we pulled from the server, there were just a bunch of parts sitting on this page, and there was no PCB. Um, what this does now is if I were to go up here. Alright, there we go. Sorry about that. I lost my audio too. Alright, sorry. Now that we're back at it, here you can see the design report that it put together. So there's 8 rule violations, and they all fall right here, which is silk to solder mask, which we're not going to worry about. That's not something you'll have to worry about as just designing the circuits and laying out the boards. So it appears as everything's fine. Something you would want to look out for is like an unrounded net. That's a problem because that means something's not electrically connected. Um, or like clearance constraints, that type of thing if you have it set up. So in this case we're all fine, so that's good to go. That's just a good thing to run when you're finished to make sure everything's okay. So we're going to close that. We're going to come over here, save what we have on the board, um, and then the next thing to do is, as I was saying, to commit to the server. If I were to actually go over here and go version control, commit whole project, what that does is it takes what are the changes I've made, throws it on the server, and if someone else were to pull down from the server, they would see the changes that I've just made in this video. they wouldn't see the original just parts on a schematic sheet as it was at the beginning. Now I'm not going to do that only because I don't want to overwrite what we have up there so that you can pull from there and get started yourself. Um, so I'm not going to add this right now, but if I were to, you could still go back and find previous revisions of different boards. When you commit, it asks for um, like a little text box comes up and says, hey, like what changes have you made? And in that box, you would write a few brief descriptions of the changes you've made to the board when you commit it. So that's about it. Feel free to explore around and play with this a little bit, make it a little more complex if you like, or take a look at the existing boards we have up on the server already. But aside from that, it's been great. Let me know if you have any questions about this tutorial. I apologize for it being a little lengthy. I just wanted to explain it clearly, or as clearly as I can at least. I haven't made a software tutorial before. This is my first one ever, so it may not be the best, but I hope it works for you. So reach out to Josh or myself with questions, and we'll move on from there. Hope you learned something. Talk to you later.